Okay, so in solving a problem like this, it's still under trigonometry. You need to consider the quadrant that the angle is in. But first of all, we need to solve it. The question says 2 sine x is equal to 1 over 2. 2 sine x is equal to 1 over 2. Let me write the 2 properly. Closer. 2 sine x is equal to 1 over 2. So what do? You have to first of all find sine x. How do you find sine x? What can we do to find sine x? Anybody?
Sine x.
If 2 sine x is 1 over 2, what is sine x itself? When you divide both sides by 2, the 2 here, the 2 attached to sine x will cancel out. So can I just tell you divide both sides by 2? What I'm writing down is not something that you are not familiar with. If I had 5x equals 20, how will you find x, for instance?
0.25.
No, how will you find x? Assuming I had 5x equal to 20, how will you find x? You can answer me. How would you find x if you had 5x equal to 20? Is it not to divide both sides by 5? Divide both sides by 5 so that 5 will cancel out. Then you now have 20 over 5. So that's the same thing I applied here. That's what I applied in this question. You have 2 sine x equal to 1 over 2. So divide both sides by 2 so that the 2 will cancel out 2. So you're going to have 2 sine x over 2 equals half over 2. Or half divided by 2 is the same thing. So 2 will cancel out 2. And you're going to have sine x. Just a moment. You will have sine x equals half divided by 2 is what? Let me write the 2 with a different color so that it doesn't look like. So divided by 2. So what's half divided by 2? By the way, this would have cancelled out this, leaving only sine x. So what is half divided by 2? Somebody was giving me the answer. That's 0.25, right? Which is actually 1 over 4. 0.25. Alright, so what do you do at this point? I hope you're still responding. What do you do at this point? Can I hear you?
We divide both sides.
We have done that already. We have divided both sides by 2.
You do s sine inverse of 0. So I literally got this thing right.
Or let me see. You probably got part of it. So let's see. You do sine inverse of 0.5.
That's 14.4. You said 15. I was close. You weren't close.
Hold on. No. You do sine inverse of 0.25 to get the values of x. What is sine inverse of 0.25? What is 14.4, right?
Yes.
14.4. Okay, but that is not just all there is. There's more. Then you need to apply this thing. Let's talk about it. Are you ready?
Yeah.
Let me zoom in so that we can see better. Let me zoom in so that we can see this better. You need to consider this diagram. In the first quadrant, all are positive. In the first quadrant means between 0 and 90. Any angle between 0 and 90, all are positive. I will explain what that means. In the second quadrant, that is between 90 and 180, only sine and of course cosec. Don't bother about the cosec because you don't need it except you are doing add maths. So I will just cross it out. Only advanced students will need it. By the way, cosec means 1 over sine. Cotangent means 1 over tan. Secant means 1 over cos. So don't bother about it, you don't need it now. But then, in this first quadrant, which is between 0 and 90, all of them are positive. In this second quadrant, which is between 90 and 180, only sine is positive. The rest are negative. In the third quadrant, between 180 and 270, only tangent is positive. The rest are negative. In the fourth quadrant, between 270 and 360, or back to 0, only cosine is positive. The rest are negative. What is the implication? What is the implication of this? Now the implication is, you look at what you are solving, because we do another one that has a negative. Look at what we solved. This value 0.25 is a positive value. It's a positive value. It's a positive value. So we're only going to where sine is positive, because the 0.25 is a positive value. Compare it with something like this. If I had written sine x equal to minus 0.25, this time around it is a negative value. But the question we are solving is a positive value of sine x. Positive value of sine x. So we go to where sine is positive. I will show you, it's actually very easy. Just stay with me as I'm explaining it. So I said it's a positive value. We are going to only where sine is positive, because it's about sine. It says sine whatever equal to whatever, and it is positive. So we go to where sine is positive. So which quadrant is sine positive? Tell me. Which quadrant is sine positive? Tell me. Let's go.
So I don't understand.
Okay, what I mean is, from what I showed you, I told you all are positive here. In fact, all actually means sine, cosine, and tangent. All of them are positive in the first quadrant. But for the second quadrant, which one is positive? It's written.
Sine.
Only sine is positive. Second quadrant actually means 90 to 180. Between 90 and 180. In the third quadrant, which one is positive?
Tan.
Only tan.
Tan.
The rest are negative. In the fourth, only cosine. The rest are negative. So I said what we are solving has a positive value of sine x equal to 0.25, and this is positive. Positive, like if you write a number without any sign, it means it has a plus. So we need to go to where sine is positive. That's what I'm saying. Where is sine positive in this quadrant?
The second quadrant.
The second quadrant, good. And of course the first quadrant, because it says all are positive in the first quadrant. So first and second quadrant is where you get sine positive. It's going to be clear. Just continue to pay attention. Don't give up. In the second quadrant, you will do 180 minus the value of that angle you got. 180 minus theta. That's for second quadrant. By the way, this is second. This is first. When you go to the third quadrant, I think I can use a different color. Let me write this with a blue. S, tangent, and cosine, and all of them, which is first quadrant. Now for the third quadrant, which I will write in green, the third quadrant, this is what you do. Don't worry, it will keep getting better as I progress. In the third quadrant, you will do 180 plus that theta. In the fourth quadrant, please, you need to stay far from each other. in the fourth quadrant, you're going to do 360 minus that theta, where theta is the angle you found. Okay, so let's go. Let's go. You said sine is positive in the first and second quadrant. So, and I said, by the way, the value of the angle is 40.5, right? So I will just write theta equals 40.5 to start with. Theta is equal to 40.5. So I'm coming to only where sine is positive. The first is already 40.5. We've gotten it. The second, I said it is 180 minus theta. 180 minus theta. Where theta is that angle you found. So the two answers will be, the two answers are, the first one, A, is that value you got. So you can call it theta 1, 14.5. Then the second one, of course, this one is in the first quadrant. Theta 2, which is the second answer, is also where sine is positive. The next place sine is positive is here. And you will do 180 minus theta, where theta is that angle you found. So 180 minus theta, that gives us 180 minus 14.5. I think that should be, what's 180 minus 14.5? Help me with the calculator. 180 minus 14.5. That should be 165.5.
No.
165.5.
165.5.
Yeah. So I was right the first time. I know it will not be so clear with this first example, so I will give you another one. Stay with me, don't give up. I will give you another example. Let me use another example to explain it better. This is the first example. So let's look at example 2, which I will call B. Let me do 3 cos x is equal to maybe 1/4 or whatever, or 0.5 or whatever, or even 2. Let's say 3 cos x equal to 2. How do we solve this? Let's go. What did I say you should do to solve this? At least, yeah, go ahead.
Such that we should divide both sides by 3.
Good. Divide both sides by 3. At least you can start with that. Let me write this thing again. This is 3 cos x is equal to 2. So divide both sides by 3. You're going to have cos x is equal to 2/3. Is it not?
Yeah.
So find, to get theta, I will write theta. Let's just be following these steps. Let's get theta. Let's get this theta. So theta will be what? Theta will be sine, cos inverse of what? Cos inverse of 2/3.
Sorry, I have a question. The theta 2, do they always ask us for it?
Pardon? The theta
Do
2.
they always ask us for theta 2?
Should they? What did you say again?
Do they always ask us for theta 2?
But that's actually a very beautiful question. It depends on the range. I should have mentioned this to you earlier. Here they said you must walk from 0 to 360. So you have to get all the angles inside this range, 0 to 360. So you need to look for where sine is positive in all the quadrant, because all the quadrant is 0 to 360. That's why we found another place. We have the first place, and then we have another place where sine is also positive. The third quadrant and the fourth quadrant, sine is not positive, so we ignored it. Don't worry, you see sometimes it may be up to 4 places. Let's do this one first of all. I will treat as many examples as possible, and then of course it will get better. Let's go.
48.24.
So theta is 48.24. With angles, you write to 1 decimal place, 48.2. Now it is about cos. This question is about cos. Where are the quadrant that cos is positive? Because the angle we are looking for is a positive value 2/3. Tell me all the places where cos is positive. The third, and of course the first, where everything is positive. In the first, both sine, all of them, sine, tangent, cosine are positive, because it says all are positive. By the way, they say a simple way to remember this. You can use these mnemonics. All students trust Cambridge. A for all. You would have heard about it before, or is it the first time? All students trust. Okay, maybe I should be writing it close to it. It will help you to remember. All for A, students for S, trust for T, Cambridge. For C, all students trust Cambridge. We used to remember it with all students take coffee. All students take coffee, Alright, so that's one way to remember that. Yes, so for cos, because we are looking for a positive value of 2/3. You said it is in the fourth quadrant, and of course in the first quadrant. So for the first quadrant, theta 1 is what? Therefore, theta 1 is that value we have, 48.2. The next place that cos is positive is in the fourth quadrant. So that's theta 2. So what should theta 2 be? Somebody should tell me. Unmute and say something, every one of you. Let's go.
Theta 2 should be
remember how we found
180.
No, this is the way to find anything in the fourth quadrant.
360 minus 48.2.
It's getting clearer now. 360 minus 48.2. What would that give you?
311.8.
311.8 degrees. These are the two answers. Sometimes you may get up to 4 answers, or 3, or sometimes 3. So let me show you a situation where that can happen. Hold on, first of all. So, but before we go to that, I say whenever you are given a question, you need to look at the range. The range here is from 0 to 360, so you look at all the quadrants. Sometimes they may tell you 0 to 180, so you look at only the first 2 quadrants, quadrant 1 and quadrant 2. But it says 0 to 360, so we are considering all the quadrants. Now, if you are given 2 sin x equal to 1/2, divide both sides by that number to have only sin x. And when you get sin x, like sin x is 0.25, find the angle, which of course is sin inverse of 0.25. That gives you 14.5. That's the theta. Then you look for where sine is positive, because the value given here is positive. So in this quadrant, sine is positive in the first quadrant, which is the theta itself, and of course the second quadrant, which is 180 minus theta. Every other quadrant, sine is not positive, so we ignore. It's tan that is positive in the third. It is cosine that is positive in the fourth. So there are only two answers, theta 1 and theta 2. Now the second question, 3 cos x equal to 2. Do the same thing. You divided both sides by 3. You found cos x equal to 2 over 3. You found theta, which is cos inverse of 2 over 3, and you got 48.2. Now you also look at where cos is positive, because 2 over 3 is positive. Cos is positive only in the first and the fourth quadrant. First and fourth quadrant. The first is that theta you got. The fourth, to get fourth, you do 360 minus theta. To get second, you do 180 minus theta. To get third, you do 180 plus theta. Alright, let's look at this other example. Let me give you this one. So I can give you 5 tan x is equal to minus 1. Can we do this? What do we do? Are you here? I need you to respond. I need your response to be sure you're here.
Yes, sir. I thought I was muted and I was unmuted. So I'm here. Yes, sir. I'm here.
Okay, so what do we do?
Divide both sides by 5.
Alright, so we have tan x equals minus 1 over 5. So what do we do now to get x, which is theta? Theta will be equal to
do the inverse. That's 78.
Tan inverse of. Please, I want to tell you this. When you are doing it, please pay attention. When you are doing it, first of all, ignore the minus. Just get tan inverse of 1 over 5. First of all, just ignore the minus. This is only in one place that you ignore the minus for a reason, for a while. We use it later. Just do tan inverse of 1 over 5. What do you have? Give me your values quickly. Quickly, give me your values. Give me the value of tan inverse of 1 over 5.
Your mic is not
Mute your mic so that there won't be no interference. Tan inverse of 1 over 5. I need an answer immediately. What's tan inverse of 1 over 5? Can I have the answer for tan inverse? 11 point what? 11.3. Though you can, well, since it's not the final answer, it could have been to 4 significant figure, but let's just leave it as 11.3. Okay, so we go to our quadrants. I will repeat the quadrant here. You know, the first quadrant, it is all. The second quadrant, it is only sine. The third quadrant, it is only tan. That is positive. The fourth, only cos. Are you ready? But what we are looking for is a negative value of tan. Negative value of tan. So we go to where tan is negative, not where it is positive. First of all, where is tan positive in this quadrant? Where is tan positive? You can answer me. Where is tan positive in this thing we normally use?
The T.
It's positive in the
third quadrant.
The third. And of course in the first now, because first is everything. And also in the first. That's where it is positive. Plus. Plus and plus. In the third and in the first. Because first, all of them are positive. But what we are solving is a negative value. So we should go to where tan is not positive. So where is tan not positive? Let me even write it. Which quadrants or quadrant is tan negative? Mutes. Which quadrant is tan negative? That's the question.
So this is a positive.
Remember, I had to ask you positive so that you can please see the positive. But the question we are solving is negative.
It's C and S.
The question we are solving is for -1. So it is positive in the second, negative in the second and in the third. Remember, in the second you do 180 minus theta. In the third you do 180 plus theta. In the fourth you do 360 minus theta. Alright, so you told me for negative, because what we are solving is about negative. So where tan is negative is in answer second and third. Second and third. And fourth, sorry. Second and fourth. Fourth quadrants. So let's start getting our answer now, since we know it will be in the second and fourth quadrant. So theta, there will be only two answers, the one for second and the one for fourth, because only second and fourth quadrant that tan is negative, because what we are solving is about negative. So theta 1 was how do we get theta in second quadrant? Tell me, how do we get theta in second quadrant? 180 minus what now? That is, which is 11.3, and that gives you what? 168.7. So the second theta, since there are only two places, theta 2. Where did you say it is also negative? Oh my goodness, this is fourth. I wanted to write fourth here, I wrote third. And you didn't correct me. This is fourth. Where is it also negative? In the fourth one, is it not? So what do you do in the fourth one? What do you do in the fourth one?
You do 360 minus 11.3.
Do 360 minus 11.3. And that gives you
348.7.
348.
Yeah, 348.7.
0.7.
Or 0.7, yeah.
These are the answers. Look at this other question I'm going to give you. Cos, I can say 4 cos x is equal to minus 3. How do we solve it? Let's go. You know, you divide both sides by 4, isn't it? You have cos x is equal to minus 3 over 4. And I need you to give me the values of x. So theta is equal to cos inverse of 3 over 4. Give me the value. cos inverse of, I told you when you are doing it, ignore the minus first. Just do cos inverse of 3/4. We look at it later. Ignore the minus. Just do cos inverse of 0.75.
Why are we ignoring the minus, please?
We still attended to it when we were looking at where the quadrant will be. We still considered the negative.
41.4.
But when you are doing this, you just ignore it until, okay, you got 41.4, right?
Yeah.
41.4. All right, so we look at our quadrants. So we have found what theta is, and we know our all students trust Cambridge. All positive, sine positive, tangent positive, cosine positive. All right, so we got 41.5. So let's begin to look for the angle we are looking for. Is a -1 for cos. So you look for where cos is negative. Where are the places where cos is negative? The quadrants where cos is negative.
Cos negative at tan at the third quadrant.
Third quadrant and
the second quadrant.
And second quadrant. So it's about second quadrant and third quadrant.
Yeah.
So second here and third here. So we normally use blue for second. Let me maintain the other. Second here and third here. That's where cos is negative. So I can just write it. Cos is negative at second and third quadrant. Yes. Second and third. Alright, so what is in second, what is in third? Let me change the color, maintain the color we'll be using. We normally use blue here, and I use green here. So tan, we stay with green, and I use red here. Okay, so what should be the values of the angles between 0 and 180 and 0 and 360? By the way, all these questions are about between 0 and 360. So I think this should have been D. We solved A, B, C. Where do we solve? Yeah, the last one was C. So this should be D. D, let's go. So what are the values? Theta 1. Let's go. Theta 1 will be what? And theta 2 will be what? Remember, theta 1 is the second quadrant where cos is negative because it's about negative, and cos is negative in the second and third quadrant. So in this second quadrant, what do we normally do? Should I remind you? In the second quadrant, we do 180 minus theta. In the third quadrant, we do 180 plus theta. In the fourth quadrant, we do 360 minus theta. You need to remember all these things. So, okay, so what are the answers? Please answer, and let's respond immediately. Theta 1 for the second.
Theta 1 is 180 minus 41.1.
41.4, which gives what? Theta 1 is 180 minus 41.1. Which gives what?
That's not 41.1.4.
Oh, sorry, 41.4.
Okay.
I thought somebody's
138.6.
138.6. 138.6 degrees. We leave angles to one decimal place. Theta 2 is what? theta 2 is in the third quadrant now. I hope you know. Theta 1 is this, and theta 2 is the other one. Theta 2 in the third quadrant, which is what? What do we do in the third quadrant? Quickly.
180 plus 41.4.
So 180 plus 41.4. And that simply gives us what?
221.4.
Okay. 221.4. This is how simple this can be. Whenever you see a question like this, that's all that you should do, and you have your answer. Okay? In solving sine, you need to, sometimes you may be asked to plot a sine graph. A sine graph usually looks like this. A sine graph is a common graph, you know. It goes like this, like this, like this, like this, and so on. So I will just say something about it very briefly. The highest point is what we call amplitude, just like your physics. The peak is the amplitude. Now, to make a full cycle, it's like completing a circle. You know, to complete a circle, you have to move like this and then back to here. So here is a full cycle, which is 360 degrees. From here to here is a 360 degrees. So this point is 360. The half of it is 180. In between will be 90. So here is, why this one is 270. The way I just got it is, I said the full cycle is like a full circle. It's half a circle, another half of a circle, which is a full circle, which of course is 360 degrees all around, full circle. So you know this place is 360. Midpoint will be 180, half of it. Then half of, between 0 and 180 you have 90. So 90 is here. And between 180 and 360 you have 270. This is how a sine curve looks. Sine graph. If you have y equal to a sine x, this is how it will look. Where a is the value of the amplitude, this a will tell you how high the graph will look. A sine x. Now the graph of cos, which I can show as y equal to a cos x, will usually looks like this. Usually looks like this. It will start from somewhere here, go like this, and then continue. You know, I can also complete it, and so and so on and so forth, you know, back to here again, and so on. So let me just show you this. It also has an amplitude. The distance from here to here is also its amplitude, which is the height. That's the value of that a, whatever the a is. An example is if I had said y equal to 2 sine x, here will be 2. 2 will be equal to the a. If I had said y equal to 5 cos x, here 5 will be equal to the value of that a. It will be as high as 5. So but it goes like this. If you notice, from here to here is a full cycle, like peak to peak. Peak to peak is a full cycle. So here will be 360 degrees. Half of it, which is around here, is 180. So you can now get 90 here and 270 here. Of course, 0 is here, just like 0 is here. So this is how some of these graphs look. The one for tangent is not periodic, so it looks really different. So this is when you are required to plot a graph of something. Let's use this small space to explain this. Assuming you are asked to plot the graph of, you are asked plot the graph of y equal to 3 sine x. It's not a big deal for maybe 0 less than or equal to x less than or equal to 360. Just prepare your table of values. Let's even prepare our table of values up here. You know, are you ready? The table of values is x values and what y values will be. You know, when you are plotting a graph, you do table of value for x and y. I think I should use a red so that this can come out better. Table of values for x and y. Okay, so when x is 0, what will be y? You find when x is, let's break it down a bit. Let's do 45. What will be y? You may want to know why am I using 45? When x is 90, what will be y? When x is 135, what will be y? When x is 180, what will be y? The space is too short. Let me see if I can reduce it a bit. Let me zoom in properly. Zoom in to accommodate more lines. Okay, so when x is 135, what will be y? When x is 180, what would be y? It's not a big deal. You will easily get all that. When x is 180 plus 45 should be, this one I wrote as 135, shouldn't have been 135 for. Give me 90 plus 35 gives 125, Abi. I have even missed one. Somebody should help me. 90 plus 45 is 135. Sorry, I think I was right. I was right the first time. So 180 plus 35 will give you 215.
315.
315, okay. The other one will be 270. 270.
585. Huh?
Oh, okay. Before 315 plus 45 will give you what? 300 and what? 85, 335, yeah.
No. 315 plus 45.
Just gives you 360 directly, so no wasting of time. Alright, so get the y values. The question we are solving is this. Y equal to 3 sine x. Let me write it up here. Y equal to 3 sine x. Y equal to 3 sine x. So it's just normal substitution. But you may want to ask, how did I come about 0, 45, 90, 135, 180, 315, 360? Sometimes these values are given. Yes, they are usually given for you to complete the table. But if they are not given, it's not a big deal. You just divide these things I talked about here. Like, I said the full cycle is 360. Midpoint is 180. In between 0 and 180, you have 90. In between 180 and 360, you have 270. You can still divide 0 and 90 to get 45. You can still divide 90 and 180 to get the 135. 180 by 270 to get the 235, and so on. But you may still choose to just do 0, 90, 180, 270, 360 instead of all those many other ones are included. You can still do that. Where are we? Where did I have the graph, by the way? I'm looking for it, I can't find it. Okay, is it here? No. Oh, it's here. Alright, give me the values. Just put these values in here. Let me zoom in a bit.
So I can't see.
Alright, so when x is 0, what is y? So you just do 3 sine 0, substitution.
0.
0, okay. So 3 sine 0 is 0. When x is 45, what is y? You just do 3 sine 45.
2.12.
2.12. When x is 90, what is y? You just do 3 times sine 90. 3. When x is 135, you just do 3 times sine 135.
2.12.
Another 2.12 again is possible. Some of them are repeated. That's what we call them periodic graphs. By the way, sometimes the table is given for you to just fill up, so you don't have to decide, oh, should I be using 0, 45, 90, 135, 180, 350. They would have been provided for you to just fill up, or they will even write some and ask you to complete the rest. So the next one is when x is 180, so you just do 3 sine 180. What does that give you?
0.
0. I believe this one with, okay, for 315, what will you get?
Minus 2.12.
Oh, minus 2.12. Is that the first time it's giving minus? Minus 2.12. Oh yeah, that's possible. After, oh my goodness, I can see I shortened this thing too much. From 180, I should have gone to 1 something. No wonder the thing just ended immediately, and I was wondering, I knew I had more to do. But I have said they will provide the table for you to just complete. But let's add some more values. It is not evenly spaced. Let's add some more values. 180 plus, that should be 235. Am I right? Yeah,
Yes, sir.
180 plus 45 should be 225, sorry. 225, maybe that's what I was trying to write.
225.
This one is 270. Okay. 270 plus 45 is 305. Happy? 315 before 360. Okay. I jumped so many of them, but it's not a problem. So just do when x is 225. Give me what y will be when x is 225. Very quickly. When x is 225, please be fast. I need your answers to be able to fill it up. When x is 225, what is 3 sine x or 3 sine 225? Quickly.
Minus 2.12.
Oh, I know there will be a repetition now. Minus 2.12.
Minus 3.
This one will be minus 3. How about 315?
Minus 2.12.
Again, for 315?
Yes.
Minus 2.12.
And 0 is the last one.
And then 0. Just plot it here, that's all. So these values, we plot them into this graph. You know, plot them into this graph, you have your answer. You just draw your graph. Is also going to be provided, the grid lines would have been provided for you to just complete, you know, for y and x, and then all these ones would have been provided for 0, for 45, for 90, for 135, for 180, for 225, for 270. I said it will be provided, for 315, and then for 360 you just plot. Okay, so when x is 0, y is 0, we plot here. When x is 45, y is 2.12, so you may want to divide this one. This is 2, so 2.12 will be somewhere here, just close to it. When x is, by the way, minus 2 will be somewhere here, minus 2. When x is 90, y is 3, so 3 will be here. When x is 135, it is 2.12, that will be somewhere here. When x is 180 is 0, here. 225 minus 2.12 is going back the other way. 225 minus 2.12 somewhere here. 270, it comes to 3. 270 is 3 somewhere here. 315, it is minus 2.12, and then this one 0. You just join the point, that's all. You join the point with a smooth curve. It's just graph plotting, which you already know. So this is the answer. And if you notice, it looks like what I told you, the sine graph. Look at the sine graph. That's exactly what it looks like. It looks like it for the first 360. Another 360 will repeat itself. By the way, here would have been another 360. If we add another 360, here would have been about 720. So it's not anything to worry about. It is a very easy math. It's just graph plotting. Confirm if you saw what I did.
Yes, sir.
And it's something you can easily do, isn't it? And it's something you can easily do, isn't it?
You are practice.
And you just plotting the table of values. That's all. Whether it is cos or tan, you plot, you get your answer. Sometimes they don't even ask you to do everything up to 360. It may just be from 0 to 180, or sometimes it might be up to 360. You just plot, and that's all.
Okay.
Okay, so